Good day, Sharon. So the question that you're given is to show that or prove that 2 to the exponent of 2011. So you're asked to prove that 2 to the exponent of 2011 multiplied by 5 to the exponent of what? 2007 is actually equal to what? 1.6 multiplied by 10 to exponent 2008. And if in case you were to put what's on the left-hand side into your calculator, you'll get a math error. And again, if in case you were to put what is on the right-hand side in your calculator, you'll also get your math error. So this means that the calculator cannot compute this, but you with the skills that you gain from laws of exponents, you can actually get to this. So so we must actually prove that this left-hand side is actually equal to this right-hand side. So we first going to what? Look at, I'd say, the tricky side, the more complicated side, which seems to be this one. And then we are going to simplify it till we get to what is on the right-hand side. So let us start. So for the left-hand side, we are given 2 to the exponent of what? 2011. Multiply by 5 to the exponent of what? 2007. Remember yesterday, what did I do whenever we are dealing with such large numbers? I looked at the smallest exponent that I have. So I have 2007. So I know that I can rewrite, I know that 2011 is just simply 2007 plus how much?
Plus 4.
Plus 4, right? I know this. So now this means that now this means that 2 to the exponent of 2011 can actually be written as what? As 2 to the exponent of what? 2007 plus what? Plus 4, right?
Yes, sir.
Yes. So now this means that 2 to the exponent of 2011 times 5 to the exponent 2007 can be written as what? 2 to the exponent of 2007 plus 4 multiplied by 5 to the exponent of what? 2007, right? And then I know that this, because I'm adding two exponents here, I can actually separate it into 2 to the exponent of what? 2007 times 2 to the exponent of what? 4. Multiply by 5 to the exponent of what? 2007. Are we okay?
Yes, sir.
So I can see that, okay, here I actually have, look at this. I have multiplication sign in between, right? And I have this exponent of 2, and I have an exponent of 2007 there, right? And then remember, I'm multiplying 3 terms. So it does not matter the order in which I multiply. So this thing, I can rewrite it as 2 to the exponent of what? 2007 multiplied by 5 to the exponent of what? 2007 multiplied by 2 to the exponent of what? 4. Are you okay with that?
Yes, sir.
And remember now, I remember that law whereby if in case I multiply powers of the same base, like a to the exponent of c times a to the exponent of d, I can actually say I'm gonna keep the base and then add the what? The exponents, c plus d, right? You remember that law? When I'm multiplying
Yes,
powers of the same base. But now what if I'm multiplying powers of the same exponent, but so I have c to the exponent of a times d to the exponent of what? A. So there's a law that says I can keep the exponent, but then I will now do what with the bases? I will multiply the bases. So this is the opposite of this law. Here, I could keep the base and then add the exponents. Here, I can keep the exponent and then multiply the what? The bases. Are you okay? Because the exponent is the what? Is the same. Here, it's the base, which is the same. But we can only do this when there's multiplication sign in what? In between. But it does not mean that if in case I have c to the exponent of a plus d to the exponent of a, this is not equal to c plus d all to the exponent of a. These two things are not equal. I can only apply this when there's multiplication, where I can keep the base, keep the bases, keep the exponent, right? I can only keep the exponent when I have multiplication only. Are you guys okay?
Yes, sir.
So this is the one that we are going to apply, right? So now I will multiply 2 times 5 and then keep the exponent of what? 2007, right? But what is 2 to the exponent of 4? It's just how much? It's just 16. Are you okay?
Yes.
So I know 2 times 5 is just 10. I have 10 to exponent of what? 2007 times 16. But look, they said I must have 1.6 multiplied by 10 to exponent 2008. But here I have a 10 to exponent 2007 and I have a 16, not a 1.6. So look now, what am I going to do? So what I'm going to do, I want this to be a 2008. So what I'm going to do, I'm going to say I have 10 to exponent what? 2000 and what? 8. But for me to go back to 2007, I must actually have a minus what? 1. And I still have a multiply by what? 16. Are you guys okay? So this and that step are still the same, right? Because if in case I minus, I go back to 2007. Are you okay? Are you okay, guys?
Yes, sir.
Okay. So now this goes on. So now I can separate this base of 10. So I can have 10 to exponent 2008 times 10 to exponent negative 1 times what? 16. So I can see I have what I want, 10 to exponent 2008. So I can leave it 10 to exponent 2008. But now let me multiply 10 to the exponent of negative 1 and 16. It's just going to give me what? 1.6 from the calculator. So now I've actually proven that it's actually 1.6 multiplied by 10 to the exponent what? 2008. So do you guys understand everything that I did?
Sir,
Mm-hmm.
why did you like 2008? Where did you get the one from?
Remember, this 2008 minus 1 is still the same as 2007. I'm rewriting it as so that I can have a 2008 because what they said I must prove actually has a 2008. And look where I was. I was at 2007 multiplied by 16.
Oh, all right.
So 2007, it's equal to, we can write it as 2008 minus what? 1. Are you okay?
Yes, sir.
And then we'll be able to separate this 10 into the same bases but different exponents. You see that?
Yes, sir.
And then now this 10 to exponent negative 1 will multiply 16 and it'll turn into a 1.6. And I have exactly now what they wanted me to prove. Are you guys okay?
Yes, sir.
Okay. So now I think all is now fine, right? So let me get on. Let me get on. Let me get on with the business of the day. So we can move on from the snack, right?
Yes.
Okay. So now we are going to surds and laws of surds, right? So you guys are not familiar with what a surd is, but you actually know it, but you haven't defined it. So I'm just gonna define what is a surd and introduce you guys to the laws of surds, and then we're gonna do a bit of examples. Yeah. So Guys, by definition, they say a surd is when a root is irrational. It is referred to as a surd. When a root, remember what is a root? A root is this sign, the nth root of a number. It's that symbol. That is so this symbol, it's the nth. It's referred to as the nth root. So in other words, if in case you have this, if you have a square root, you actually have a 2 here. So you can, a square root is actually referred to as the second root. If in case you have a 3 here, this is actually referred to as it's the third root. Do you guys understand? So
Yes, sir.
when the root is what? Is irrational. So that means that it's not, so this means that if in case you, by irrational, we mean, look at something like this. If in case I have a root of 4, I know I'm going to get 2, right? But in case I have a root of 3, it's always going to be a root of what? 3. It's going to give me something like decimals in my calculator. Root 3. It's going to be 1.73, da 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 da. You see? So this means that this is an irrational number. You see that? But 2 is a rational number. Are you guys okay?
Yes, sir.
So if in case a root is irrational, we call it a what? A surd. So now moving on. So examples, you know that a square root of 2, when you put it in the calculator, you're going to get a lot of commas, 1.4142. So this means that this is a surd. It's a surd. Square root of 5 is a surd because I'm going to get 2.23. So this is a surd. Square root of 3 is a surd. But look, if in case I punched in the square root of 4, I get 2. So square root of 4 is not a surd. If in case I punched in the square root of 16, I'm going to get 4. So square root of 16 is not a surd. So these are, you see, so you must be able to see. So these ones are what? Are irrational. But these ones which are not surds are actually what? Rational. Are you guys okay?
Yes, sir.
Okay. So now let's move on to what we call laws of surds. So just like exponents, surds also have laws. And think of it like this. You see, if in case I have an nth root of, let's say, a, it's actually going to be what? If in case you express it in exponential form, it's going to be a to the exponent of what? 1 over what? N. So do you see that a surd can actually be expressed in what? In exponential. In a surd can be expressed in exponential form. So a surd can actually be expressed in exponential form. So this is its surd form, and this is the exponential form of a what? Of a surd. So it's gonna, you keep the what's inside this the surd and then raise it to the exponent of 1 over n. So example, if in case I have the square root of 2, it's actually 2 to the exponent of what? 1 over 2. If in case I have the cube root of 2, it's actually 2 to the exponent of what? 1 over 3. If in case I have now, let's say root of 4, remember now this is going to be what? 4 to the exponent of what? 1 over 2. But remember 4 itself, it's 2 to the exponent of what? 2. So if in case I say this, I'm going to have 2 to the exponent of 2, and then all raised to the exponent of what? 1 over 2. Remember now, these exponents are going to multiply each other, and I'm going to get 2 times 1 over 2 is going to be 1. So 2 to the exponent of 1, it's what? It's 2. Hence, square root of 4, it's actually equal to what? To 2. You guys understand that?
Yes, sir.
Yes. So we can express a surd in its exponential form. Yeah. So now let's start with the first law of surds. It says if in case I'm multiplying two surds, right, of the same root. You see, this is the nth root and this is the nth root, right? But I have two different numbers inside the surds. I have A, which is different to what? To B. You see? So this means the law says I will keep the what? The surd sign and then multiply whatever was inside the two different what? Surds. You see?
Yes, sir.
Yes. Or now I can go in reverse. If in case they give me the nth root of two numbers which are multiplying each other, I can actually separate it into what? The nth root of one number times the nth root of the other number. Are you guys okay? So this is me going forward, and that is me going in what? Reverse. Are you guys okay?
Yes, sir.
So you can write down these laws. You must write them in your notebook. So now the second law says I'm dividing. So when dividing the same surds, you see I have the same nth root, but I have two different numbers under the roots. So I'm gonna keep the surd sign and then divide whatever number was at the top with the one at the bottom. Do you see that?
Yes, sir.
And now if in case I'm given an nth root of the top number divided by the bottom number, I can actually separate it into the nth root of the top number divided by the nth root of the bottom number. Are you okay?
Yes, sir.
So these are laws. Remember, in mathematics, we don't make up our own laws. We are given these laws, and then we should just simply abide by them. So now I actually added my own law. Yeah, it's actually law number 3 actually deals with addition or subtraction of sets, because here we dealt with what? Multiplication, division, and I thought, okay, we should also deal with addition and subtraction. You see. So check now, you'll have a number outside the nth root of a certain number plus another number in front of multiplied by the nth root of a certain other of the same number. You see. So what can I do in this case? I can actually add the numbers in front and then keep the nth root of that other number. So I can actually treat this. I'm actually treating this kinda like a highest common what? Factor. I'm treating it as a highest common factor. Do you see that? Because I've taken it out and then added these numbers which are in the front. Do you get that?
Yes, sir.
Okay. But now when you have numbers in front attached to different nth root, you see this is the nth root of A, this is the nth root of B. So in this case, you cannot just simply add. You cannot just add these things. It's gonna be difficult for you to do this because it's an nth root but of A, but here we have an nth root of what? B. So you see, we cannot just simply add. You understand?
Yes, sir.
We can only add when we have nth root of the same number. You see, even when we subtract, I have C multiplied by the nth root and D multiplied by the nth root of this. But now it's the nth root of the what? The same number A. So this means now I can take out this A as this nth root of A as a highest common what? Factor, and then multiply and then minus D from C. So that's why I have C minus D times the nth root of that A. Are you guys okay?
Yes, sir.
Okay. And then now I wanna go to an important thing. Uh, so the an important fact, yeah? An important fact is this one. The nth root, right? The nth root of a number raised to the exponent of n is actually equal to that number. So what do I mean by this? Look, for example, right? Let's say I have the nth root, I have the square root of 2 raised to the exponent of what? 2. Remember that the square root of 2 means that there's actually a 2 there. Guys, a square root is the same as me saying 2. Right?
Mm.
Yes. So this means in case I have the square root of 2, this just means that, remember, I'm going to first start by writing what is inside in exponential form. So I'm going to have 2 to the exponent of what? 1 over 2. Right? All to the exponent of what?
Yes.
Of 2. So this exponent times that exponent is just going to be 1. So it's going to be 2 to the exponent of 1, which is just 2. Hence, the answer of this is just whatever is in what? Inside. So the nth root of a, all raised to the exponent of n, it's just whatever is left in what? Inside. Do you see that?
Yes.
Yes. So now I think we can go to examples so that you guys can see how we apply these laws, because we can only understand laws by applying them in problems, right? So if in case
Yes, sir.
if this link expires, just log on to the other link. Is it okay, guys?
Yes, sir.
Okay. So let's continue. We are left with like 10 minutes. So check. I have the same nth root. I have the nth root of two different numbers, and there's a law of multiplication. It says if in case I have the nth root of two different numbers, I can just keep the nth root and then multiply the two numbers. So it's gonna be 2 times 3, which is just gonna be the square root of what? 6. Is that okay? From that law,
Yes, sir.
multiplication law, I have the nth root of two different numbers multiplying. So add the square root of two different numbers. 2 times the square root of what? 3. It's actually going to give me the root of 6. Are you okay?
Yes, sir.
Here, just give me the answer straight from your head. It's going to be how much?
4.
Hmm?
It's gonna be
Yeah.
4.
It's going to be 4. Why?
4.
Because I know I can write whatever is inside in exponential form, right? So it's going to be 4 all to exponent of what? 1 over 2. All raised to exponent of 2. And these two exponents are going to cancel each other. So I'm going to be left with what? 4. Is that okay?
Yes, sir.
Okay.
Yes.
So now remember now here, what I'm doing, I have the nth root, the cube root at the top of 16 and the cube root of 2 at the, so I know that this can be just equal to the cube root of, I can just keep the cube and right, and then have what? Divide these two. So I'm gonna have 16 all over 2. This is gonna be the cube root of 16 divided by 2 is what? Is 8, right? And the cube root of 8, you can put it in your calculator. You're just gonna get how much? 2.
Mm.
Are you okay? Because there's
Yes,
this
sir.
division that says if in case I have the nth roots of two different numbers dividing each other, I can just keep the nth root and divide whatever is in what is inside. Are you okay?
Yes.
So here I was dividing 16 by 2, which is gonna give me what? 8. And then I'm just gonna put this all in the what? In the calculator. Are you okay?
Yes, sir.
Okay. So now, yeah, I think we are done with the first two laws. Let's go to the third law, which is adding or subtracting. Look now, the problem gave me 5 square root of 3 plus 2 square root of 3 minus 3 square root of 3. So what should I first check? Are the nth roots, before I can add or subtract, are all the nth roots of the same number? Let me check. Here it's an nth root, it's the square root of 3, the square root of 3, the square root of 3. So this means what? I can just simply add and subtract whatever is in front. So I'm going to have 5 plus 2 minus 3. And then I keep the nth root of 3. So what is this going to be equal to? 5 plus 2 minus 3 is going to be how much? Guys, 5 plus 2 minus 3. It's actually equal to what? To 4. So I'm going to have 4 square root of what? 3. Are you guys okay? So here,
Yes.
you can just say that we took out, you can think of it as, here we took out square root of 3 as a what? As a highest common factor. That's what we did. Are you guys okay?
Yes, sir.
Okay. So now let us continue. Let's go to letter B. So here I'm given square root of 7 plus 2 square root of 7 minus 6 square root of 7, right? So what do I first check? Are all the nth roots of the same number, right? Here I have the nth root of
Yes.
7, nth root of 7, nth root of what? 7, right? But who can tell
Yes.
me how much do I have in front of the 7?
1.
I have 1, right? So I can actually write this as what? As 1 plus 2 minus 6. And then I take out nth root of square root of 7 as a highest common factor. So I'm going to have, again, I'm going to have negative 3 nth root of what? Square root of 7.
7.
Are you guys okay with the laws?
Yes, sir.
Yes, sir.
So in other words, for here, we can think of us having taken what? Root of 7 as a what? Highest common
Common
factor. Are you guys okay?
Yes, sir.
So we've applied the laws. You guys have seen the laws, right? You guys have seen the laws. So, guys, can I please ask, how far are you at school with the maths curriculum?
We are currently at exponents.
Hmm?
We are currently at exponents.
Okay.
We're doing factorization.
Okay. Okay. That's good. That's good. Okay. So, but in most cases, just know that I'll either be ahead or on par with your teacher, right? In most cases.
Yes.
So let me go back. So now I'm gonna go to the textbook and then try to find uh, some questions for us to do. Oh, then yeah. hmm Yeah, let's just find some problems. Let's find a bit of problems. Mm, yeah, I think we can try to do A. Mm, yeah, A, B, and C. We can try to do them. So now let's continue. Guys, when the link please click on the second link. So now check for letter A, what do we have? We have the square root of 7 times the square root of 3. So I have the same nth root, which is the square root. So I can just multiply the numbers which are what? Inside. So I'll have 7 times 3, which is the same as square root of 21. Are you guys okay?
Yes.
Okay, so letter B, let's move. So letter B, I'm given the nth root of 7 times the square root of 7 plus square root of 11 all squared. This can just be what? Taken as I have the same nth root and the same number. So I'm going to have nth root of 7 times 7, right? Plus,
7.
I have the square root here and then I have a 2 here. So those two are just going to cancel each and I'm going to be left with how much? 11, right? But
Yes.
then if in case I take this and put it into the calculator, I'm just going to get how much? 7. So I'm going to have 7 plus 11, which is just equal to 18. Are you guys okay?
Yes, sir.
Okay. So let's move on to letter C. So for letter C, we are given 2 and root of 3 all squared, right? So I know that this 2 is multiplying the square root of 3, right? And this is all squared. So I will take this exponent and give it to each base that is inside, right? So I'm going to raise 2 to the exponent of 2 times root 3 all to the exponent of 2. So for here, I'm going to get a what? A 4. But here, this square root and that 2 are going to cancel each other. So I'm going to be left with what?